So far, for solving for mechanical advantage, we've been using something called ideal effort force. And an ideal effort force is fantastic for introducing the concept of solving for mechanical advantage.
Using cross, multiply, and divide. But the deal is,
Ideal effort forces only exist in theory.
in theory, IMA equals AMA, and therefore we can use our equations, gears are free. But in the real world, this is not the case. In reality, the AMA is always smaller than the IMA. And if you think about it, this is kind of obvious of why. And the reason why is IMA is literally the ideal mechanical advantage. That's what the I stands for, literally, an ideal world. So in other words, in a perfect world, a world without friction, let's say. And since the IMA is based on distance, it's not really affected by friction. And actually, let's add in, to make this a proper sentence, and is based on distance, or at least more proper. So yeah, the IMA is the ideal mechanical advantage and is based on distance. And distance is not really affected by friction in a system where energy is lost, which is basically every system. And then the AMA is literally stands for the actual mechanical advantage. In other words, it's in the real world. And the AMA, actually, and the AMA is based on forces applied. And some of that force applied is canceled out by friction. And since some of our force is lost through friction, we also lose energy through friction. And this is what efficiency is for. Efficiency is basically a percent of energy lost. That's what it's measuring. So it measures how much energy is lost from the IMA, or the perfect world, or in theory, to the AMA, or the real world, or in practice. So how much energy is lost from theory to practice. So here's the deal with efficiency. Here's how it works. The rule is nothing is 100% efficient. Nothing in the world. We always lose energy in any system where work is done. So energy is always lost. Energy is always lost in any system. And we really should say some energy, because not all energy, just some, a small percentage. And sometimes it's a large percentage, and we'll talk about that. But like we said, it's lost to things like friction. Things like friction. And other things that might be lost. So what if your force isn't going in the correct direction? So to make this a little bit wider. What if your force is a little bit off angle? Well, you'll lose some of that by the misdirection of the force. And we'll talk about this more when we get into Unit 2. But this misdirection of forces might be caused by pushing things off angle, or instability in a structure, or things like that. But the point is, we lose energy to things like this. And there's an equation to figure out how much energy we actually lost. So efficiency is a percentage. So to measure that percent efficiency, or percent E, we set it equal to AMA divided by IMA. And then we multiply that fraction by 100. And yes, it's always a fraction, because AMA is always smaller than IMA. Which means this fraction here has to be less than 1 always. Which means the percentage always has to be less than 100. Because if it can't be 100% efficient, it certainly can't be 110% efficient. That would be defying the laws of physics. And you are not allowed to defy the laws of physics in my classroom. But yeah, this is percent efficiency and how it works. And in the next couple of videos, we'll give some examples of using the equation for percent efficiency to calculate efficiency lost from IMA to AMA.